Okay, so this is notes 10 4 radical equations, page 151 of your notebook. And this is 5/13/2020. So if you square both sides of an equation, the equation is true because it's going to be, because you're squaring both sides. It's an equivalent idea. So in other words, if A equals B, then A squared equals B squared. So that's understandable. If you square both sides, it's still going to be an equal equation. Inversely, if the square root of x equals 4, then the square root of x squared equals 4 squared. So you're squaring both sides. So taking the inverse operation, so x equals 16 if you were to solve that. So with that concept in mind, we're going to do many of these 4 problems. One is really lengthy on the right side. So the first one is the square root of t equals 8. To get rid of that square root, we square. That's the inverse operation of a square root, is to square it. So we square both sides. The square root of t squared is t. This 8 squared is 64. So that's how you would solve number 1. Number 2, 9 equals 1.34 times the square root of L. To solve for L, we first get rid of the number 1.34 because it's attached to the square root of L by dividing. The inverse of multiplication is division. That's not a multiplication symbol. It's the radical sign part. Okay? And divide by 1.34. 9 divided by 1.34 is 6.7164. It keeps going, but I truncated it to 4 place values. Equals the square root of L. Then we're going to take the square of both sides to get rid of the square root, and we get L equals 45.1. Remember, you turn it around and leave the L on the left side, 45.1 on the right side. Now, example 3. If we have the square root of A plus 5 underneath the radical sign plus 7, we first subtract 7. Then we have the square root of A plus 5 equals 5. We square both sides. I don't like my equal sign here. We square both sides. So the square root of A plus 5 quantity squared equals 5 squared. The square root of A plus 5 squared is A plus 5. Therefore, now we subtract 5 from both sides and get A equals 20, and we're done. Okay, we could substitute in and get 20 to see if this is right. 20 plus 5 is 25. The square root of 25 is 5. 5 plus 7 is 12. So that's how you would check that. You need to check it because of a situation like this. So this is example 4 and the last example. If you have the square root of x plus 1 equals x minus 1, you get rid of that square root by squaring both sides. When you square both sides, this becomes just x plus 1. This becomes a binomial times a binomial because x minus 1 quantity squared is x minus 1 times x minus 1. Now you got to FOIL this part. So you have x plus 1 on the left side. On the right side, x times x is x squared. Outside, x times negative 1 is negative 1x. Inside, negative 1 times x is negative 1x again. And then negative 1 times negative 1 is positive 1. Then you add these two like terms together here, negative 1 plus negative 1, and get negative 2x. So your right side becomes x squared minus 2x plus 1. Now you set everything equal to 0 and solve, if you remember that. We're going to subtract 1 first and get x on that left side equals x squared minus 2x. Minus 1 plus 1 drop out or simplify to 0. Then we're going to subtract x from both sides. You could do it both at the same time, but I did it in 2 separate steps. X minus x is 0, so we get 0 equals x squared minus negative 2x minus 1x is negative 3x. Now we factor this. Take out an x and left with x minus 1. If you remember that x times x is x squared, x times negative 3 is negative 3x. Now from there, we set each one of these products equal to 0. X equals 0 or x minus 3 equals 0. We solve each one, x equals 0. Solve this one by adding 3, x equals 3. Now you have to check to see if 0 actually works. If you put 0 in, you get the square root of 1 on this side, which is 1. If you put 0 here, you get negative 1. 1's not equal to negative 1, so you can't use 0. 0 does not satisfy the equation and can't be a solution. Now 3 can. If I put 3 in here, I get the square root of 4. The square root of 4 is 2. And then 3 here, 3 minus 1 is 2, so 2 equals 2. That would work. I didn't write it all out. That's how that would work. Okay, so sorry I didn't go down there. Let you see that. Sorry I didn't follow that down. So 1 is not equal to negative 1, and then 0 does not satisfy the equation. Whoops. Sorry, I didn't see that. So that's why I crossed out x equals 0 right here. And those are examples to work on your assignment. Good luck.